Okay, today's topic is CAD and digital fabrication. Our class name is CAD and graphics. CAD and graphics, but today's topic CAD and digital fabrication. As you know, CAD means computer-aided design. Computer-aided design for graphics. Simply say, we have been working for CAD and graphics, especially focusing on design representation, design presentation, design development, design visualization, okay? Of course, design visualization is one of the main objectives of CAD, okay? Digital tools. The reason why we are using 3D applications like SketchUp, AutoCAD, 3D Max. But today's topic a little bit different. Digital fabrication purposed CAD, okay? That's why I brought the title CAD and digital fabrication. I'm not talking about conventional, classic fabrication method, okay? Some kind of handmade, okay? Now we are talking about some digitally augmented manufacture method, so-called digital fabrication, okay? As you know, we are in 12th week and also have an exam at the end of today's class. But we need to do lots of things, okay? Lecture for an hour, the lecture topic, digital fabrication, and the lab exercise, series of lab exercises, okay? AutoCAD to SketchUp and rendering, modeling, review, as well as developing your final project. Next week, one of the given homework is bring your SketchUp or any other 3D model, including CAD file, mostly your SketchUp file, for your final project, okay? I'm going to show you today the example SketchUp model or final presentation based upon last semester's your senior students' work or some former students' final project work. Again, final project listed here. So hopefully this slide explains you what you need to prepare for the final project, okay, without any problem. Basically, design presentation. So how to present your design? Actually, fortunately, not your design, okay? Already examined, already well-developed professionals' design, okay? That's what you choose last week. So what you need to do is to maximize the meaning of the design intent of designers' design, original design intent, to represent on top of your computational model as well as computational representation. For doing that, what you need to do? Figuring out design concept, design development, progress, 3D model, visualization, and so on, okay? Anyway, I'm going to show you in the lab exercise hours for your progress, okay? So series of given topics, design subjects listed here. Okay, let's get back to the course material. Today's topic, CAD and digital fabrication. Not just graphics, but also we are dealing with fabrication issue today, okay? But actually this is freshman course, so I like to bring your attention, especially focusing on 3D printing, okay? That's why I brought 3D printing. Okay, to make computational models for your design. What's next? That's the question. As you know, we are creating computational model because we have an idea, okay? We have an idea of geometric shape, design, form. That's why we are working on computational models. What's next in this frame? Of course, extracting floor plan drawings, sections, elevations, line stroke styles, V-ray renderings, lots of additional design representation things such as animation, walkthrough, video, and so on. Okay, PowerPoint slide, blueprints, drawings, 3D renderings, and so on. So all they created, extracted from your computational model. So this simple iteration, okay, your concept, your idea, build your computer model, extracting representation, drawings, visualizations. If you want to update, go back, update your design or update your computer, okay? Some recursive process, iteration. That's simply the process of design. But what's next? That's the question. Of course, your design basically aims to be realized in real world, okay? But in school, it's not easy to experience this kind of realization of your design, okay? It's not easy. If you are in industry, your design is supposed to be realized, actualized in real world, erected in real site, on site. But in school, our iteration going to be staying in this small time frame. But today's topic is something different. For realizing design, of course, there is on-site construction process, okay? For on-site construction, take a look. Some interior finishing work by several workers and some structural installation. Workers are working with this one, with lots of additional devices, facilities. In general, for one building, around 1,000 people involved for one project, okay, one single building project. On-site construction, of course, very important, but actually there are something more, okay? How about shop fabrication? The term shop here means factory, okay? Some parts can be assembled, pre-constructed at specific site, specific shop, specific factory, okay? Pre-made objects can be transported to site and finalized on site, okay? That is why we usually say shop fabrication. And also prefab. Prefab means prefabrication. Something needs to be fabricated before actual installation. For example, window frame. Totally new design of window frame, wall frame. They need to be prefabricated at a shop, at a factory, and must be tested, okay, again and again, until the final production could be realized without any problem, and then transported to on-site and assembled at the end. Rapid prototyping. Rapid prototyping means creating a markup model. Take a look. This is markup model, okay, not real model. 1 to 10, 1 to 20, 1 to 50 size, small size prototyping model created by some specific computer tools, okay, computer generation tools. At the beginning of design, at the early phase of design, before construction, okay, in order to figure out whether this design is sustainable or not, and many reasons, okay? So today's topic actually in this field, in this area, okay? We are talking about something shop fabrication, prefabrication, and rapid prototyping using 3D printers, CNC machine, laser cut, and so on. Such digitally augmented fabrication methods, okay? That's the topic today. So digital design and fabrication. For handling digital design and fabrication, I like to show you one case study, okay? 2 years ago, 2014 summer, some students have been at Georgia Tech, US senior students, okay, at Georgia Tech for the summer program, just 2 week, 2.5 week intensive program. At that time, the course title was Digital Fabrication, okay? So at that time, the subject was interior panel. What is interior panel? Take a look. This is one type of interior panel, another type of interior panel, and here is interior panel. So this kind of panels can be usually created by designers, handmade. Take a look. Someone can make this kind of interior panel design using some knives, cutting wood by hand. But anyway, nowadays, of course, they are all digitally fabricated interior design panel. So that was subject, and we build some teams. Okay, 3 students, 4 students, 1 team. So total 6, 7 teams built at the time. So each team required to create their own design. Okay, digital design, and usually, in general, digital design and critique, final presentation, and that's it. But in this digital fabrication class, we really fabricated, okay, using CNC machine, using real wood or some MDF structure, thermoforming, laser cut, water jet, 3D printing, lots of equipments we used, okay, for making their design. So digital design, that's not the end of this project. We have to make. So we need to add another process, simulation, okay? Simulation means one type of additional task for realizing their design without any problem, okay? Simulation first, and if we found a problem, design should be modified. Without any problem, of course, simulation successful, and then we can create, we can make, okay? Digital fabrication method, it's up to fabrication method, up to fabrication device, okay? So let's take a look. We used Rhino Grasshopper as a design tool and AlphaCam as a simulation tool, CNC waterjet laser cutter, 3D printer for fabricating methods, okay? So here is the example. If we have this kind of wood structure, this is AlphaCam simulation screen. Take a look. This drill is moving on top of this wood structure, and then physically, really, this wood structure can be cut by this drill, and then final products can be created like this way. So here are some examples of design. Group A, B, C, their design concept, their design algorithm, and final visualization results. Okay. Actually, this is the end of their design process, but at this time, they were asked to make, okay, to fabricate by digital fabrication machines. So let's take a look. Here are some design presentation, and real screen, and some screenshots, real picture. At the end, at the final presentation, thermoforming. This is plastic, okay? Thermoforming wood and some layered wood structure, and so on. They created, manufactured. So at the end, all these are real picture, okay? Not computer file, not computer-generated visualization. All they are real picture. And also, I have those structure. We have this one. And they're going to be not yet displayed, but they're going to be displayed in our exhibit area. Anyway, take a look. What we need, the reason we need to take some simulation is they should be examined. Okay, the behavior of fabrication machine should be examined before actual fabrication. Let's take a look at this demonstration video, okay? Okay, this is the simulation screen, okay? Here is the drill machine, and this one going to be moving like this way, and then your design can be realized based upon this process. Okay, this is the process of simulation. So let me quickly move. At the end, we can find out this one can be realized in this way. Okay, next video will show you real production of this one. Okay. Take a look. This is CNC machine, and there is a real drill object. And take a look. This MDF, 1 feet by 1 feet by 1 feet by 1 feet size wood can be manipulated like this way. Okay, this is CNC machine, totally computer controlled structure, and there are bunch of drills. Okay, different size drills, and then design can be controlled and manufactured by this machine. Okay, this is the shop. Okay, shop at Georgia Tech, digital fabrication lab. And the third one, demonstration video. Take a look. Pre-fabrication, after that changing the drill, and this one is moving here, and some smaller sized drill going to cut the edges, okay, like this way. Okay, CNC machine means computer numerical control. So the movement of this drill carefully controlled by computer. Okay, where the location of this drill and the thickness of this drill, size of the drill, and the X, Y, Z location point, 100% controlled by computers. Okay, why controlled by computers? In order to create any kind of geometric shape designed by you. Okay, so that is why we could generate those structure. Let's take a look some more example. At this time, as I showed you before, in our device lab, our equipment lab, there is 3D scanner like this. So even if you don't have some computer tools, anyway, we can get this kind of 3D shape, okay? And then we can print them out using 3D printers. So scan the geometry. Also, I introduced you before, 1 to 3D Catch application, your smartphone application. I don't know, you have this app on your smartphone device. Anyway, that is free Autodesk application, 1 to 3D Catch. So I'm going to show you how to use that kind of application apps for your design or 3D printing and so on. Take a look. Physical design panel object. This is real panel object, okay? But by using pictures, by using your smartphone, taking series of pictures, okay, like this way, and then the geometry can be imported to your computer tools in order to edit, okay? Simply edit, unnecessary geometry can be removed. You can add some more or modify using this kind of tools. At the end, take a look. This is computer file, and this is real product. So this is kind of reverse engineering. From this real world object, by using your smartphone or using just laser scanner, our department has. You can use them, okay? You can use your smartphone. You can use your laser scanner. And then this kind of physical thing can be converted to this geometry, computer file, okay? And this is actually Revit application, and you can reuse the given design. Design from real world can be used in this way, okay? So Revit family into the design project. So this one, at this time, one example of Revit family application from not your tool, not your head, okay? From not your brain. In this case, this one is not your design. You simply copy this design, reuse design, but not this is a picture. If this is a picture, this one cannot be installed in this way, okay? This was importing geometry based upon your scan. That's the point, okay? And also this one, of course, can be printed out. Next topic is 3D printing. Why 3D printing is so-called ground shaking technology? Why people say this is ground shaking, okay? Because it's a new way of digital fabrication. So let's take a look this example. Actually, now you know how to use AutoCAD, how to use SketchUp. So if you create this kind of 3D object using SketchUp, you can import this one, you can load this one, and easily create your own 3D printing object, okay? 3D printing material without any problem. So let's take a look this one. Here is the example, okay? Okay, here is two objects, okay? This is this structure, okay? Simple sort of geometric shape, and this one is something like freeform shape, okay? So how to put this one inside of this structure without any cuts, without cut or glues? Of course, it's not possible, okay? Simply because A is bigger than B. But what if you print this out in this structure, and then this one is moving inside, okay? This one is exactly placing inside of this structure, but you cannot get this out, okay, without cuts, okay? So how to make this kind of structure without 3D printers? Not possible, okay? That's the point. So let's take a look this demonstration video and the time-lapse video. This one simply shows you how 3D printer is working, okay? So the same 3D printer, okay? The structure is looking like that. Inside of the 3D shape can be manufactured like this. And this is time-lapse video, total around 2 hours, 2 hours time-lapse video taken by my iPhone, okay? Take a look. Inside the structure, exterior structure, they are building at the same time like this way. The height going to be going down. In other way, Z direction going to be changed by controlling this plate. And this one is moving XY direction, okay? And then final products can be created like this way. So here is the object printed out. And let's take a look, more example, another one. Please take a look this example. Okay, here is one single object, okay, rectangle shape object, and they connected others like this way, okay? In 3D way, But looking them carefully, one single piece placing without any touch, okay, with others. But they all connected. So that is why this kind of 3D chain can be created, okay. So this one is looking like just plastic, and this one is looking like wood structure because this is wood material, okay. Wood, precisely say, wood looking filament, okay, wood looking material for 3D printing. Anyway, take a look. The structure is totally connected each other and kind of new type of chains, okay, 3D chains. In conventional way, we need to create one piece by one piece, and we need to cut and connect by hand, one by one, and glue. That's conventional production process. But thanks to 3D printing, we can simply print them out, okay? So take a look. This one is actually the original printout. Take a look. This one, for making this one, okay, here is something. Take a look. Something, okay, it's not easy to see, but okay. For making this kind of structure, we need lots of additional parts, additional pieces, so-called support, okay? We need to make support first, and then, thanks to the support, this kind of structure can be made on the air, okay? Thanks to the support. So after the manufacturing, after the printing out, this one, okay, take a look. This is support structure, okay? This kind of support structure supposed to be created for making this one. And take a look, lots of unnecessary support part we have to get rid of this from the structure like this. And then we can get the final products, okay, like this way. This is the way of creating objects using this kind of 3D tool. Okay, this is sometimes very annoying, okay, time consuming, but anyway, we can get the geometry exactly what you want. For your design studio, your structure creation class, you can use this one, okay, for making this kind of innovative structure and so on. Let's take a look. Let me tell you how to actually print, Here I simply list up the process, very easy. What you need to do is save your file in OBJ format. OBJ is one of the 3D file format, okay, object file format. Even SketchUp can export OBJ file, okay? Your SketchUp model can export OBJ file from your design, anything else. And you need to simulate and convert it to G-code file. G-code file is exactly what you need to get. Okay, G-code file for real printing software, okay? Real printers. Printers recognize G-code file. How to create G-code file? How to convert G-code file from OBJ file? Using the software named Simplify 3D or similar tools, okay? This computer and another computer in device room, one of computers has Simplify 3D software. This software is in charge of converting OBJ file to G-code file. This is simulation passing file, okay? Based upon this one, anyway, saving this G-code file into SD card, and then you can print out. Okay, you can print this out. So let me show you the demonstration. At the beginning of the process, you need to use SketchUp or 3D Max, Revit, Rhino, Maya, whatever it is, OBJ file. That's the file you need to export. And then open it in Simplify 3D. This is Simplify 3D application. But take a look, the reason why we need to use this kind of application. Take a look. This is the geometry. This is the geometry you designed. And take a look this box. This box is exactly same to the physical size of this printing box. Okay? So this one should be a little bit modified in terms of its scale, location, direction, and so on. And then the finalized ready, 3D print ready G-code file is here. So opening OBJ file and controlling geometric shape, controlling size, and simulate. Let me show you the simulation example, simulation demo. Take a look. This is the real size of the products. And here is the object. And you can control the sequence of production, sequence of printing. Take a look. So this is the simulation video based upon this structure. Red line means the movement path of the nozzle. Okay? And let's take a look, demonstration video 2. Okay, in very slow direction, you can see the movement like this way. Demo, okay, another one. Take a look. Red line means the movement path of this nozzle, and take a look, the sections. Section by section, the stacking of the section gonna create the final object like this way. So entire section form totally controlled by computer. Okay, exactly same to the CNC machine that I show you today. Of course, this kind of 3D printing machine by machine, they have some separate characteristics. But anyway, this is usual 3D printing mechanism. Okay, thanks to the G-code file. Okay, demonstration. Let me show you one quick demonstration. Okay, because this 3D printing machine is kind of ready to use. You can use them. Okay, very cheap, very powerful. So let me show you the case, the example. Okay, okay, remove this one and change camera view, parallel projection, and at this time, let me change the angle. Okay, let me draw 100 millimeter size one and front view. Okay, I just created this one and remove, and let me draw this one using follow me tool. Okay, okay, what happened? Okay, some problem. Okay, this is not the one that I want to create. I don't know why. I don't know why this happened. Okay, I don't know why this one happened. I just want to create sphere. But anyway, let's try. Okay. I don't know why, but something happened, okay? Some problem, something happened. Okay, anyway, let me export this one in 3D model using OBJ file, okay? OBJ file named BBB and export. And let me show you this one. Simplify 3D application to convert your geometry. Okay, on the C drive, let me show you bbb.obj file. Okay, here it is. Okay, some problems. This is not a good object, but double click and rescale size 30% and click center and arrange. Prepare to print, and let's take a look. Actually, this is not good. This is not good case, not good example. Take a look. Okay, from the bottom to top, something problematic. Okay, take a look. This is not good. This is not good structure. Lots of problems. You cannot create this geometry. Okay, take a look. The movement here, there is no structure. In this case, how to make this one on the air? Okay, this one getting kind of collapsed. Okay, so this is not possible to create. Okay, instead, let me show you a better one. Okay, let me show you my case, my example. Okay, on the 3D printer, let me show you this one. Okay, take a look. That's me. Okay, the size is too big, so let me rescale 20% and arrange to center and prepare to print. Let's take a look. This one. The inside structure of this object is looking like this. Okay, and then the final product can be created like this way. Okay, so this is the way of creating object using 3D printers. So the file for defining this process is so-called G-code file, and you need to save this one into this SD card. Okay, so making your object anything else using SketchUp, 3D Max, and save this kind of G-code file into SD card, and then simply plug into G-code and click print, navigate to your file, okay, and let me print. Okay, start. So printing bed and the nozzle is going to be heated, okay, to 170 or around 200 Celsius degree, very hot. So you should be very careful, okay, very hot. Anyway, nozzle, after heating, bed means this one, okay. After that, this one is moving. What I need to do is clicking, print, that's it. So this file prepared in this software, original design file can be prepared by SketchUp, 3D Max, whatever, okay. That's why you have learned 3D software, SketchUp. But actually, next year, we're going to use this kind of tools carefully, precisely controlled by 3D printer. Actually, SketchUp 3D is not that good, okay? Not that precise. I found lots of geometry errors when we create 3D printing files using SketchUp. But Rhino is really good. Rhino is a really good application for 3D printers. So anyway, if you have file, try to test print. Just in Korea, 1,000, 2,000, 3,000, enough, okay, for material fee. Very low expense, okay? Okay, that's it for today. Let's have a break and then move to the lab exercise today, okay?